Hello everyone, welcome to this video. In this video, we shall be looking at an application of the external direct product to cryptography. You know, cryptography is a science in which data is to be encrypted. So that means data is protected from hackers and other peoples who may misuse it, right? So we will see the application of groups and in fact external direct product of groups to this cryptography. So let's move forward to this video. All of us know that computers, they are built from two-state electronic components, right? What are those components? Those components use 0 and 1 format. So 0 represents the off situation, 1 represents the on situation. So whatever is the information that is processed by these kind of computers, they basically use it in this binary string form, right? So any information is first of all converted into strings which contains 0 and 1s, right? For example, we have one such strings. Now you can think of this particular string as so you can represent this particular string as this kind of tuple, where what we have done over here, we have just inserted commas in between all the numbers, and now you can see how many elements do we have. We have 1 2 3 4 5 6 7 and 8. So in total 8 elements present in this tuple. So you see each 0 and 1 is a member of the Z2, that you already know, 0 and 1, correct? So this is a group, right? And moreover, the operation here is addition modulo 2. So here each 1 or 0 is assumed to be taken from this group Z2. So therefore we may assume this to be some element within this group. What is this group? This is the direct product of the groups of addition modulo 2, right? And we are taking such direct products how many times? 8 times. So we are including 8 such groups here. Why? Because we have element of this kind only. So therefore you see how we have related this binary structure of the computer with that of group theory. So how group theory plays a very important role in this cryptography and in the use of computers. So thus, you know, if someone has learned about this addition and subtraction of binary strings, then you could also relate this concept very much clearly. Even if you have not studied about it, with the help of group theory you would be able to understand it very easily. So suppose we have two such groups, two such strings. One is a1 a2 up to an, another one is b1 b2 up to bn, right? Now we wanted to add both of them component wise, and how we will do it? We will do it modulo 2. Why? Because we are in the group direct product these one, right? Where our individual groups, they are finite groups under the operation of addition modulo 2, right? So how do we add two strings? For example, I have considered here two examples. In the first example here, I have considered this string and I am adding this string to it. Now let's see how can we perform this addition. So you see, we now need to add 1 plus 0. So we will add 1 plus 0, which is 1, and then we will take mod 2 of it. So it is just 1. So we have 1 here. So you see, we are doing the calculation in under mod 2. Next, you see, when you wanted to add 1 plus 1, its answer is 2, and then we will calculate 2 mod 2. 2 mod 2, when you divide 2 by 2, you will have 0 as the remainder. So 0 is your answer, right? In a similar manner, we have 1 plus 1 as 0, as I have told you. 0 plus 0 is 0, 0 plus 1 is 1, and 1 plus 0 is again 1. So similarly, you can see if we add one string to the same string, right? So what do we have here? You see, we would have the string which contains only the zeros. Now what does it mean? It means that this string is the inverse of this string. So the string is itself the inverse of itself, right? Because this gives us the identity here. So basically it means that when we add the same thing to the same thing, we will get back the original thing, which is the identity. Okay, so now how can we apply this concept for cryptography? right? To encrypt our data, to secure our data, whatever information we have, how can we use it to secure our data? So let's see an example, a case study for that. So suppose you wanted to purchase a compact disc or anything from Amazon, right, which is an online shopping platform. Now you have a fear that if I buy something online, so that whenever I would like to make a payment for that, I would have to give my credit card details to the to Amazon, which is not safe because any hacker might get your details and you have a fear of your account to be hacked, right? So what should you do? So basically you should not fear about this transaction. Why? Because the credit card number that is sent very securely on the web in such a way that it protects your data. It does not provide your data to go to anyone. So how is this thing done? So let's have a look here. So whenever we place some order, suppose with Amazon, then the company sends us a computer generated string of zeros and one, which we call a key. So what we do, all of these things, it happens behind the computer, so we are not able to actually see what is happening, but all of this thing occurs so that our data is safely passed on to Amazon in order to purchase the goods. So Amazon first of all sends us a key, right? This key is nothing but some combination of zeros and ones of this kind, right? So this key would have the same length as the binary string which corresponds to a credit card number. Whatever credit card number do we have, it will first be converted into binary string. Whatever is the length of that string, the same length key would be sent to us by Amazon, right? Next, what they do, they add together these two strings so that they would have some binary string here, right? So whatever is the result, whatever is the sum, that is transferred to Amazon, right? This is sent to Amazon. The sum thing is sent to Amazon. So how does Amazon get back the original number? The original binary number is obtained when they add this same thing to this answer, because you know, when the same thing is added to the same thing, you will get back 0. So that means this cancels out its effect, right? So this is what we are doing. Again, Amazon, what does it do? It adds the same string to produce the original string, and this original string is nothing but your credit card number. So in a way, it unlocks your data. First of all, we have locked our data when we added this key to our data, right? Now after sending it to Amazon, Amazon unlock it by adding the same string. But now the question it might come to your mind, that what if someone on the internet got to know about this added key? So are they able to get our credit card number and details? Will our data be still safe in that case? So the answer is yes. Our data would be safe in this case. They would not get to know about this string, because whatever is the key which is sent by Amazon, that is randomly generated. So nobody knows about what is this string except Amazon at that particular order for that particular time, right? And this is only used one time. So that means again, for some other product or for some other customer, another key would be used, and so on. So therefore, for each transaction, this key would be changed, and hence our data would be absolutely safe. So your credit card would be safe in this case. So I hope you understood this application of this direct external products to cryptography. Well, that is it for this video. Thank you for watching.